Good afternoon, good morning, good evening, ladies and gentlemen, wherever you are in the world. This is Tim Collins. We are now going to officially start the webinar this afternoon entitled Stainless Steel Food Boxes for Hygienic Lifetime Use. Before I start going through the presentation, just a few housekeeping points. So everybody who is registered and logged on to this presentation will get a copy of the presentation pack. So there is absolutely no need to ask that as a question. I'm going to speak for somewhere between 40 and 45 minutes, which will allow us sufficient time for questions towards the end of this hour. And I would ask that if people want to pitch questions, please wait until we get to the end of the presentation. You can pitch questions through the online chat function, so you can type in your questions and we'll amalgamate similar questions if we have the same or similar ones coming in, or you can raise your hand when we get to the Q&A session and we can unmute you, and then you can ask your question live, so to speak. So sit back. I hope everybody's comfortable, and for the next 40 minutes or so I'm going to go through a number of features. The first thing I want to draw everybody's attention to is the agenda. For anybody that's been to the World Stainless webinars or joined the webinars before, this agenda is a little different. We've got 4 introductory parts because I think there are a number of things we need to bring together. And the first one is a brief history of food boxes that dates back a long way in time. I will also sort of have a brief introduction on stainless steels. Most people will know some stuff on stainless steels, some people will know less. And then I'll be talking about stainless steel boxes. And then we'll talk about stainless and metal taboos before getting into some more meaty stuff and some rather controversial stuff at times in the bottom list of the agenda. So I hope that's all clear for everybody. And moving into the first part, we'll do a brief history of time for food boxes. And actually the origins go back to the 12th century as far as we could research, with the Japanese bento box sort of originally being used for food products. And these are always attractive boxes. And over the next few hundred years, the appearance and decor associated with these boxes became more elaborate and more compelling and interesting. But by the time the 17th century arrived, bamboo boxes were becoming quite common. And not so much changed across these sorts of variants. Things were fairly static for a few hundred years, but aluminium boxes bounced into our world early in the 21st century, which is perhaps earlier than some people would expect. And plastic boxes became very popular, particularly from the 1960s, I should say. And many people will remember a certain brand having home-based parties to promote and sell plastic food boxes and boxes for other uses. Then as we moved into the 1970s and the notion of takeaway food started to really ramp up, even though it clearly existed before that, both plastic and aluminium boxes became the mainstay for those carry out or takeaway foods. And then as we move more up to date, we see that cardboard boxes are now featuring more for takeaway food. So there's a whole sort of procession of change over quite a number of years, and you can see the speed of change in the last few decades being much higher than perhaps the speed of change in the past. And there's good reason for that I'll touch on a little later in the presentation. Now let's look at things from a slightly different perspective. So this is controversial red flag number 1. So do we have today a societal problem? If you look at the image here in the top left of the slide, you'll see what we all see on a daily, weekly basis in supermarkets and stores, rows of ready-made foods in plastic boxes. And I would argue that is a societal problem, because with only 9% of plastics being recycled across our world today, where the hell is the rest going? We have a huge reliance on plastic food boxes. And I think we've normalized this feature as a society. We just think this is the norm without worrying about where these things are going because we like choice and convenience. And this is a societal driver, I firmly believe. But I think as an intelligent society, we need to think differently and demand what is right, not accept what we're given. So I think there's a whole question in this area. And the image in the top right shows a very attractive lunch, I guess, in a cardboard box. So things are possible. Change is truly possible. But we've got to drive this as a society, as a set of industries. We need to come together and put pressure on people to change. So now I'd like to sort of switch tack a little bit and just talk about stainless steels. And for people that don't know, the first stainless steels were created in 1912, 1913. I'm a fan of 1913 because I'm British. Other people have slightly different views. But over the last 111 years or so, we've become very used to stainless steels. And I'll just sort of walk through a few applications that we're familiar with and some that maybe we're not so familiar with. But one thing that's really important here, you'll notice that I'm using the plural, stainless steels, not the singular. Stainless steels are several things, many things. More than 200 different grades of stainless steel exist today. So we should never talk about it as stainless steel. It's not one thing, it's many things. But we'll all be familiar with stainless steel in our homes, whether it be cutlery, cupware, dishwashers, other domestic appliances. That's the norm. We equally will be aware of stainless steel in healthcare settings, whether it be surgical equipment, hypodermic needles, sample bowls, etc., etc. It's used all over the healthcare industry. In buildings, we probably notice it and don't always pay attention to it, but elevators, handrails, building cladding, stainless is a common product in these applications. On our streets as well, we're seeing more and more stainless steel seating, barrier systems to offer pedestrian protection, waste bins, and other uses. But also in our process plants, whether that be chemical processing equipment, food and drink processing equipment, etc. Stainless steel is a material of choice in these demanding, hygienic, high intensity applications. So I think it's fair that we can say stainless steels have many fantastic attributes. The hygiene factors are supreme, the corrosion resistance, there's a whole range of excellent corrosion resistance products you can get out there to deal with all the different forms of corrosion. The formability of stainless steels, the strength and the ease of cleaning. This is a family of products that is truly fantastic, but the right selection of the right grade for the right application is always important. So let's now jump quickly to stainless steel boxes, but I'm just going to walk through a couple of things. If you look to the left-hand picture, you see all the common things people see in their kitchens today made of stainless steel, and we accept this. This is very normal, it's fine. And I've touched on some of the reasons why these things are important, the hygiene factors, the corrosion resistance, the ease of cleaning, but also these things look superb, whether it was bought 100 years ago or today. And from a food perspective, stainless steels are one of the few materials that are truly food safe. They satisfy all the legislation that exists around the world by some significant margin. So we have a very strong product. Now, if we think about stainless steel food boxes, which is the sort of core of this presentation, boxes have been around for some time. They're not brand new in terms of stainless steel, but probably they've not made a dramatic entrance either into the sort of world of use that is primarily aligned to domestic appliances. I think all people have maybe seen stainless steel big boxes for food when there's been hot buffets served at functions. That's fairly common. But the smaller personal boxes, less so. And now we have the microwave safe boxes. These are relatively new. And of course, this is always going to cause some concern because putting metals in microwaves is is a concerning and perhaps challenging and something that needs further understanding. But these products are here. So let's move on to the stainless taboos. We cook with stainless steels on our hobs, our stove tops, and in our ovens. We're very used to that. But when it comes to microwave thinking, the instructions are always don't put metals in microwaves. We are instructed not to do this. And that's because there is a risk of electrical arcing or sparks inside the microwave ovens. Or is there? And I'd just like to hold that thought, because this notion of sparks in the microwave ovens is generally between metals surfaces. From metals to the oven walls, if you've not got a coated oven wall, some microwaves are stainless interiors. Between metal surfaces, from sharp-edged metals, anybody that's inadvertently put some aluminium foil into a microwave and switched it on will know what I mean. It's not a good sort of unfolding event. It's rather worrying and scary. So there are some concerns, but can we manage this? We'll come back to that later. So I'd now like to switch tack completely and go back to the mid-1950s, the dawn of the disposable society. Life magazine, 1955, introduced throwaway living, where a family of four could happily live on takeaway meals, and all the equipment needed to eat and enjoy that meal and the drinks that go with it was supplied, and at the end everything went into the trash can. That's where everything started, in my opinion, to go somewhat wrong, because the notion of single use hit us at this point. And by contrast, the notion of reusable products, the example of the stainless steel boxes here, brings a different way of thinking about things. So that's the fundamental of changing our societal position away from the disposable society. So, as I said, the disposable society arrived in 1955. Life magazine can be credited or criticised, or whatever your viewpoint is for this, but our adoption of single-use food containers came rather rapidly after that. And there were various materials, as we've touched on already: aluminium, plastics, more recently cardboard. These things are around and are still used in huge amounts. I think at the minute, across the planet, 7 billion single-use plastic food containers are used every year. Not small numbers. These are big, big numbers. But let's look at some of these materials and the concerns associated with them. So I'll start with aluminium, and I rather like aluminium. I know I'm a stainless freak, but I rather like aluminium. It's a great product, lightweight, very flexible in its uses, but it is a widely recognized toxin that inhibits more than 200 important biological functions, not all in mammals, some in the sort of plant world as well. There is this link that's been around a long time to neurodegenerative diseases like Alzheimer's. And I remember my parents throwing away their aluminium pans in the 1970s because of research in this area. And you can look at all the data behind this, and it still does not make the case clear whether aluminium is a cause of Alzheimer's or the accumulation of aluminium in brains is an effect of Alzheimer's. That's still unclear. But what is known, and there have been a number of cases around the world, is that where drinking water has been contaminated with aluminium, neurological impairments have followed in the communities affected. Some of those impairments short-lived, some longer term, but that link is definitely there. And I'm going to come back to aluminium in a moment, but just hold that thought. When considering plastics, we've got a different sort of piece of knowledge that's hitting us now and has come about in more recent years, that when you stick a plastic container into a microwave oven and power it up for 3 minutes, you get a massive release of microplastics per centimetre squared of plastic area. And that's worrying because the microplastics are already known to damage renal cells. What that damage actually means is not fully understood yet, but there's certainly a concern there. And there is further research ongoing to look at the impact on neurological functions, because these microplastics cross the blood-brain barrier quite quickly. So there are issues to concern ourselves with there. But we should equally consider cardboard containers, which are a more new kid on the block product. I mean, cardboard containers, I remember as a child for dry foods, perfectly suitable, nothing wrong with them. But when you come to wet foods, they result in some degradation, understandably, loss of strength, loss of integrity of the food box. But if we look around now with the cardboard containers, many are lined with plastic films. That enables the packaging of wet foods, and that's helpful. But also, if you've got plastic liners, you're going to attract, particularly if you put these things into microwaves, the diffusion of microplastics again. But also, to offset that, there are some natural cellulose linings in place. So the cardboard packaging industry are addressing this issue as a concern, and that's really good. But I can't tell when I look at these cardboard packages what's got a cellulose lining and what's got a plastic lining. I really do not know. And I hope that it's more cellulose than plastic, but I don't know for sure. So cardboard containers, I think, have less concerns, but still have one or two. But let's just jump back to aluminium for a moment, because I think it is understood that aluminium can leach into foods under set circumstances. If you've got an acidic or a highly spiced food combined with high temperatures greater than 150 centigrade, you can expect some leaching of aluminium. And red meats and poultry particularly are known to absorb aluminium during cooking. But to sort of be fair to aluminium, it's also said that the notion of neurodegenerative diseases is really associated with excessive aluminium intake, if it can be proven. And that is quite unusual for somebody to be cooking these sorts of products under these conditions repeatedly for a long, long time. And aluminium works perfectly for cold food and for cooked takeaways that are then packaged in aluminium. There is no real problem there. So I think we have to look at aluminium with a fair set of eyes to say, yes, there are some concerning areas, but also to get to that level of concern has to be quite intensive and extensive use of aluminium at high temperatures. If we go to plastics, then we've got some further considerations. I've already talked about the sort of micro and nanoplastic release, and that's come from research in China, the UK, and the USA in the last few years. But also with plastic containers, you can get this notion, particularly if you reuse them, and this is a reused takeaway food container, that at the meniscus line between the food or liquid and the container, you get locally melting of the plastics. And this photograph is an example of that. The white marks are where at that meniscus line, the plastic has locally melted and actually been lost into the food. Now, I've got no idea how good or bad that is, but it doesn't sound good to me. It's not something I would want to experience on a repeated basis. So I think there are other concerns that come with plastic containers. And equally, if you sort of refer to the Food Packaging Forum, they would say that, you know, almost 200 of the defined almost 400 chemicals of concern are known to be used in the production of plastics that then come into contact with food. So, you know, is this problematic? Again, I'm not sure, but it's worrying, I would say. So plastics undoubtedly carry some health concerns, and probably undoubtedly further research is needed. So let's try and sum up the disposable society. There is no doubt, I wouldn't argue with this, it's brought a huge level of convenience. I enjoyed much of that convenience as a boy and a young man. But has the notion of smart marketing and pursuit of low costs overridden the health and hygiene issues? And most of us, I would argue, have accepted and embraced the changes without thinking about those hidden health and hygiene issues. Furthermore, the disposable society has been around for almost 3 generations, so it's fully embedded. It will be hard to overturn because we've just got used to this, and I include myself in that. But I think we all have this responsibility to drive and force a change and do things that are better and different. And in that, what I mean is that we must drive a shift towards sustainable and fully hygienic materials. I don't think we can accept anything less. Compromise shouldn't be the way forward. We should shoot for the best. We're an intelligent society. So let's move now to choosing the right food boxes. So, first of these slides, as you've seen, there's quite a few material choices for food boxes today. When it comes to boxes that we put food in that we make and store, we have our own choice. We can decide what material to use. That is within our control. That's quite easy. For things that we buy from supermarkets and takeaway outlets, they come ready boxed. We get what we get. It's more difficult to influence, although there are companies like Returnsy in Canada that now have stainless steel food boxes in this supply chain. So you can say, when you order your takeaway, I want it in a stainless steel box, please. It comes to your property. When you've emptied it, you don't even have to wash it out. You just put it in a recycle bin on the street, and the Returnsy people collect it, wash it, and it goes back to an outlet. So there are people actually doing something interesting in the takeaway arena, and that will develop over time. But generally, we have no choice there. But how do we know what is the best material alternative for us? Because these things are embedded in our society. When we pick up the phone or go online to order a takeaway, do we think about hygiene factors and human health? Do we think about the environmental issues? Do we think about the ease of use and the economical value, not just in the moment, not just the upfront cost, but over a longer time? So I've put together a bit of a chart for choosing the right food boxes. I've got 9 features or attributes down the left-hand side, and this is a simple color coding thing. So we've got 2 different types of plastic: glass, stainless, aluminium, cardboard in here. Dark green scores high, red scores low, red is poor. We've got the safety of the food in the boxes, what I've called the barrier properties. Do those materials release things into the food or not? Are they sustainable materials? What's the carbon footprint like of the materials? How's the item cost look? What's the life cycle cost as well? Because I think we have to move to life cycle thinking. Are these products easy to use? Are they reusable? Are they recyclable? And when you look at that, you get an interesting picture that the plastics tend to score poorly on barrier properties, sustainability, recyclability. And I think that's a fair reflection of how we are today, with only 9% of plastics recycled, many plastics going to landfills, into oceans and being burnt. These are not what I would call sustainable products. I think when you look at glass, glass has very few weaknesses compared to the others, but it doesn't have many superlatives attached to it as well. So it's a good all-round product, I would say. Stainless always loses out on item cost, but wins on life cycle cost. Life cycle thinking is important. Aluminium loses out on the carbon footprint and a bit on its barrier properties, but is not bad overall. And then cardboard really loses out on the reusability because it doesn't tend to have that function today. But what you start to see is quite a polarization in this sort of basic scoring system, that you get a number of materials that perform well and some that really perform less well. And I think this sort of thinking should inform our choices. So moving on, I think when you look at that range of products, stainless, glass and cardboard have some solid attributes. And I would argue that should be in our top 3 choices for material for food boxes, but in different sort of considerations and applications. Stainless is by far the most expensive, but it has the best attributes overall. Glass, I think, is the next. It has some strong attributes. Cardboard is low cost, but clear limitations. So it's a horses for courses product, I would say. And then together, I would argue these 3 materials are the optimum choices, particularly compared to plastics. I think we can't ever dismiss aluminium, but it does have some concerns. But I think there's products that we should choose over plastics. So if we think about that top three, for home use, stainless steel is arguably the best material choice because it's hygienic, it's long lasting, it's damage and corrosion resistant, and the high initial cost is more than offset by the very long usage life. I think glass performs well but has some limitations. We've all broken glass in our lives. It's normal, it happens. But the other thing that many people don't know about glass is because glass is a supercooled liquid, so it carries with it something known as Griffiths flaws all over the surface of glass. You can't see them, they're very small cracks in the glass, but the more you put the glass through a heat and cool cycle, the more those flaws open up and small shards of glass can drop into your food. This doesn't happen very often, but it does happen and we should be aware of it. I think equally for glass on the upside, the recycling credentials are pretty okay. They're weaker than stainless because I think in glass recycling it's probably only around 45 to 50% recycled compared to 95% for stainless and other steels, but it's not bad. Cardboard, absolutely low cost, safe, but has versatility limitations. So some concerns for cardboard, but it has its place. If we take a different consideration, look at the store food sales route, I would argue that stainless steels are the most optimal material choice. However, the cost of stainless boxes will not be easily supported for the use of stainless perspective with the existing supply chains in place, because the existing supply chains are all about piling up set shelves, selling the products as cost efficiently as possible, and that's not going to happen with a stainless box solution. But if we can move to a refillable outlet in stores, that offers something quite different. And then stainless has a part to play, and there are these refillable stores coming at us now. So there's no reason why refilling couldn't be a clear sales channel where stainless is the material of choice, because you would get on top of that less waste, both of the box materials and the product you're buying as well, and reduce the use of unsustainable materials. But I think the big question here is, would the actors, the current actors in the supply chain, actually accept that as a notion? Have they got too much to lose? And I think it's probably yes at the minute. So this could be a slow burn, but it's not a reason for saying no. We should try and force change. So as we get into the last section of this, I'd like to sort of move towards stainless steel food boxes specifically now. Now, there's some things we know about stainless steel food boxes, and we've used them for some time, or some of us have anyway. They're perfectly safe in the freezer. But whilst this photo is very picturesque, you could argue, from a sort of marketing perspective, you shouldn't be removing stainless filled food boxes from a freezer with your bare hands. You're just asking for a world of pain and uncomfortableness for a while. So please, if you do this, always use protective gloves or a small towel. You don't want your fingers sticking to the frozen stainless. It's not pleasant. But they are freezer safe, the products. Equally, they're oven safe, and the same warning goes here. You know, don't touch the hot boxes with your bare hands. Use oven gloves or something similar. But also, for the stainless boxes, take the lids off. You'll generally find that the moisture loss is not high in stainless boxes compared to other boxes, which is quite an interesting reflection. But when you're using in the oven, cook with a lid on, unless the recipe specifically says cover, then put some aluminium foil on. There is no problem with aluminium foil in a traditional oven. Dishwasher safe. We know stainless steels are dishwasher safe. We've all put our cutlery, pots, pans in there. These boxes are just the same. So you can safely clean them in dishwashers for many, many decades. But then we get to the question mark, microwave safe. Well, we've recently into our society found microwave safe stainless steel food boxes. I've been in touch, or one of my team has been in touch with TUV Rhineland to say, hey, we've seen certificates out here saying these food boxes are now certified to standard EN 15284, year 2007, and they've confirmed they are genuine certificates that they have approved. And this is materials and articles in contact with foodstuffs, the test method for resistance to microwave heating. So TUV Rhineland are quite sort of happy that these products do satisfy this standard. Now, I should say this standard doesn't actually specify stainless steels in it, and I guess that's something that does need to be changed in the future times. But we do have an organisation, a well-respected organisation, that are certifying these boxes now and have confirmed that that is the case. But is this the end of the microwave safe question? No. So now I'd like to move to metals in microwaves. And I think it's fair to say that putting metal things in microwaves has been historically discouraged. Certainly that's how I was taught by my parents when they first got a microwave. And the recommendations in the guidance we get with our microwaves is to steer us away from putting metals in microwaves. But if we have these boxes, what do we need to understand? Because microwave ovens themselves are a metal box with either stainless steel or coated steel interiors in the main. And we don't normally see arcing inside our microwave ovens under normal usage approaches that we've all learnt over many years. But if you do inadvertently, and I know I did it when I was younger, put some additional metal inside a microwave, then arcing did occur. And in my case, I put some aluminium foil on top of a plastic box and there were quite a few sparks flying around. I quickly corrected that. That's not good. We don't want things like that. But I guess most people have made a simple mistake like that at some point. But let's take an interesting couple of examples here. This is a well-known brand of frozen concentrated orange juice. It has two metal ends. One metal end can easily be removed to access the frozen juice, and the full can be placed in a microwave and the orange juice effectively defrosted or turned into liquid without any arcing inside the oven. It's a relatively modest amount of metal, but even on full power, this thing doesn't cause any problems. So you've got a tear off metal end on one side and a fixed metal end, and it's the bit at the bottom that stays in situ during the defrosting process. But we're also, in more recent years, familiar with metal grill grids in microwave ovens, and they're generally provided with the combination ovens. But of course, they don't cause any problems at all. I use these things on a regular basis personally. I've never exhibited a problem. But of course, when you look at the structure of these, there's not much metal. There's a lot of space between all the metal rods in there. And that's another interesting reflection. So if we think about unusual situations, situations that could cause us some challenges, putting a large volume of metal into a microwave, I would certainly say is a problematic area. Something greater than 30% of the oven volume, that's going to increase the likelihood quite sharply of getting arcing. I think inputting aluminium foil, I've inadvertently done it myself and I've seen the outcome of that. It's not good. Other metal foils will do the same. You get a lot of arcing, and the aluminium foil tends to sort of actually you end up with holes in it as a result, which is really not good. A metal on metal contact is not going to give you a good outcome. So a stainless steel box placed on a metal grill grid, I would say that's really not good. Two stainless steel boxes in the same oven touching each other, it's not good. And don't think that if you put two metal boxes in a microwave oven with a gap between them, they're necessarily going to stay like that. As they move around on the turntable, they get closer together. So, you know, it's something to be very aware of. There are some unusual situations. What you don't want to do is sort of damage anything, whether it be the microwave itself, your containers, or other things you put in there. So avoiding unusual situations is important. Now, I've been testing some of these boxes over quite a time now, 15 months, and I've used three different brands of microwave safe stainless steel boxes. And there is no doubt that the boxes that have a wide top opening perform best. The microwaves penetrate from the box top only because they can't pass through the stainless steel. So if you've got a wide opening at the top, you don't want a lid on it, you'll get reasonable food reheating. But also the other thing is, because the microwaves are only coming from the top, you don't want a huge depth of food to reheat. That sort of doesn't work so well. So either a shallow box profile or shallow food depth with a wide opening seem to help. And round cornered boxes suppress arcing. So if you look at all the declared microwave safe boxes, they all have rounded corners, no sharp edges, which is particularly important too. So I think these are the stronger features that if you were out looking for a stainless steel microwave safe box, you should align to. But I think there's other things to sort of sum up in this, that whilst the boxes work rather well, based on my experience, you should only place one box in a microwave oven at a time to avoid any metal to metal contact. And most of the manufacturers that produce these things now actually have that as a piece of guidance with the boxes, only one box in a microwave at a time. I think choosing the boxes, as I've said, is important. Wide top openings, rounded corners, shallow food depth or shallow boxes. Remove lids before microwaving your food. Moisture loss using stainless steel microwave boxes tends to be low. That's certainly my experience on this. And don't place metal on metal. Don't apply an aluminium foil covering. You want to get rid of sharp edges, metal on metal contact. These are not good things to do. So if we think lastly about microwave safe stainless steel boxes, I would say these are a universal product. You can use them around your kitchen, in your home, even away from your home. They're very versatile. And that's useful for our society because it means you can carry less boxes in your house. Stainless steel boxes do not carry health concerns in contrast to other materials. They're not leaching out any materials. They don't harbor bacteria. They in fact suppress the growth of bacteria and viruses. But the rules for using stainless steel boxes, particularly when it comes to microwaves, are not hard to remember. They're not hard to follow. They're just different. And we have to be a little cautious here. Now, a few contrasting pieces of information. If you buy a microwave safe stainless steel food box and treat it properly, it will last a lifetime, at least a lifetime. But it's not cheap. On average, it's going to cost you somewhere around $23 or €21 for a mid-sized box. But stainless steel products are fully recyclable, and today 95% of end-of-life stainless steels are recycled. The average cost across the world is about €200 a ton to recycle stainless steel. You might think that's expensive, but just wait a moment. Stainless steels are safe and hygienic, and they're environmentally friendly because they last a long time and they can be recycled. And actually, the carbon footprint per ton of steel over a lifetime is really low. So these are a good product. Let's contrast that with our friend, the plastic box. So the average adult will use more than 2,500 plastic food boxes in their life. That's an average adult. We know that the younger generation are probably going to exceed that, but that's roughly where we sit today. These things are cheap, but if you use 2,500 of them, you're going to spend more on the plastic boxes, or as a society we are, compared to the stainless option, a lot more. We need to think about that as well. Is that a good use of resources? Only 9% of plastics are recycled into new products, and the cost of that recycling is big, €650 a ton. So when you start to look at things from an economical perspective to society, you see quite a big difference. There are genuine health concerns emerging when it comes to plastics, and without a doubt, they're not environmentally friendly. We see on the news the damage that this is doing to our oceans, to other countries, and burning plastics and the smoke and pollutants into the atmosphere is horrible. So they're not a great product. So, with that in mind, I'll leave you with my thoughts and experiences. As I've said, I've tried 3 different brands over the last 15 months. I've had absolutely no problems with any of the boxes, but there are some important learnings. I've got a couple of what I'd call sexy tall boxes with narrow openings. They look fantastic, but they're a bit rubbish. They don't reheat food uniformly. So they've been relegated to food storage for me and reheating in ovens. But they're nice boxes. Completely filling the stainless boxes with food for storage purposes is good. It's a great space saver. They take up not much so much space, even the wide opening boxes, and they take a lot of food into them. But when it comes to reheating in a microwave, decant your food out. You want a low level of depth to get a good level of uniform heating. So it's a different way of thinking. Don't place a stainless steel box on a metal grill grid in a microwave oven. Only reheat one box at a time, and all about avoiding that metal to metal contact or the risk of it. And don't forget, metals get hot as well. So, as with a traditional oven, when you take a stainless steel box out of a microwave oven, use oven glove because it will be hot and you don't want an unpleasant experience. So, it's just another important consideration. So, to wrap up and hand things over to questions, I think there's a place for microwave stainless steel boxes. And if you haven't bought one yet, go out and get one and try it. It's not a huge investment. You'll learn something interesting and you'll probably throw away a lot of plastic boxes in the process. So I'd like to thank people for their attention. I've probably been a little bit controversial at times, but do we have any questions?
Yes, we do.
Excellent.
It's an interesting question as well, Tim.
Yeah.
What is the risk for chromium leaching out of stainless steels into food?
Well, there was a study done in 2014 at an academic institution in Sweden, if I'm right, and the leaching of chromium, nickel, iron, molybdenum, and I think 1 or 2 other elements from stainless steel was so low, it was way below the safe thresholds for food preparation and food use. And that's why I said in the middle of in the presentation, stainless steel is one of a few materials that satisfies the global food hygiene standards. And I can't remember those values, but we've got it. We have a presentation on our YouTube channel about stainless steel as a hygienic material, and that shows all those values for stainless steel in food preparation. So you can see the thresholds and what stainless actually releases, and it's way below the thresholds. So it is fundamentally a safe product for this sort of application.
I can also send along all of these documents to the person that
Yes,
asked, or anyone
yes,
who would like
for
to have
anyone,
it.
yes.
There was a raised hand, so I've unmuted someone.
Okay,
Shall I ask my question now?
Yes,
yes,
please.
please.
Yeah, thank you. This is Raman from Trichy, India. I have 2 questions. Number one, as far as our country is concerned, we are quite used to stainless steel boxes.
Mm-hmm.
So, is there anything new that you are proposing? And my second question, are there any, as a metallurgist, are there any specific grades of stainless steel you are recommending? Thanks for the opportunity.
No, great question. And it's always nice to talk about stainless grades as well. I always appreciate that. So, all the boxes I have used have been made out of 304 stainless. Um, because they've been formed, as you can see on this image now, they all carry a very small amount of magnetism coming from the coal working, but that's fairly normal. But they've either been 304 and 316, and they perform really well. I've had no problems with either of those. Um, there have been some people who believe they've had 200 series stainless boxes, and whether they are perfectly suitable, I don't think we know for sure yet. We believe they may perform less well, but nobody's tested them for long enough to prove one way or the other. So I think with the common austenitics, the 304, 316 grades, you've absolutely no problems. I think 201 may well work, but we need to assess that. But I would not choose a ferritic grade like a 430 to go into this application. I think you can expect a stronger likelihood of arcing in the oven. So all the manufacturers that are promoting these boxes are clearly wedded to 304 or 316 grades now. So I hope that answers the question.
Yeah, thank you, thank you.
There was a question about the grades to use, but I think you have answered that question. And then what about the roughness or smoothness of the surface?
Okay, well, the first thing to take into account is these boxes are pressed from a flat sheet of stainless steel which has been cold rolled. So you have inherently started with a product with a very, very smooth surface with no imperfections in it. And the pressing process does not add any imperfections. The stainless will mold around the former quite easily, but it's also worth pointing out is stainless because there is an invisible film of chromium oxide that protects the metal substrate from whatever's coming into contact. And that invisible film is self-repairing in the presence of oxygen. And that's equally oxygen in water. You know, so if the item's put in water, you've still got oxygen present, and this invisible film will self-repair. It's known as the passive film, and this is why stainless is fundamentally stainless. So even with a small imperfection, that imperfection is sort of smoothed out by the passive film. It takes care of that. So you have no problems with stainless when it comes to the existence of small imperfections in the surface. The product has some remarkable characteristics and features. And if you understand that in a basic way, you can't go far wrong.
So it says here is like a dairy grade surface.
Well, I get sort of a little twitchy when people start using terms like dairy grade and marine grade, because what's important is the roughness of the surface finish coming out of the mill or the surface center. And that's defined by the required final application. So a grade of stainless is a chemistry. What you have is a surface finish that is applicable to an application. So if you want to hold milk, you will have essentially something close to a mirror finish stainless that will be probably electro polished. Rob Cooper, who's on the line, will probably know better than I the surface finish required for that application. So I avoid the terms marine grade and dairy grade. You're looking for a level of corrosion resistance, a sort of surface finish characteristics that is applicable for the application. But unfortunately, these terms do get used and then get a little bit misunderstood along the way.
I have a hand up, so I'm going to unmute that person.
Sure.
Should be able to speak now, Mr. Hooper.
Hello, it's Greg Hooper from Camden.
Hi, Greg.
Just a couple of queries on the microwave side of these, really. The fact that the metal does block microwave energy will impact the rate of heating of a product. Have you done any work into the impact on that? So comparing a stainless container with a plastic container for the same product and the length of cook time? So that's the first question. And the second one, which from a food safety point of view is a little bit more, what's the word? You're pondering, and that's the impact on the power output of the microwave oven. So an 800-watt microwave oven is designed and will deliver 800 watts to a foodstuff, but that's not in a metal container. So that will be
No.
different. So has any work been done to look at the impact on the power output of the microwave ovens? Thank you.
Right. Thanks, Greg. Lovely questions. To answer your second question, the answer at the minute is no. Absolutely not. And I think you've mentioned that to me in the past, in perhaps one of our first meetings. So it's something I've got logged, but I definitely believe no work's been done in that area. In terms of the comparative heating, I've looked at plastic containers against the stainless containers for the same food type and same food quantity. And there is no doubt the plastic containers heat the food, or the food in the plastic containers gets heated to an acceptable temperature faster. But what was interesting is using these wide top opening containers and filling them probably 50% of the way up with food, the extra heating time was somewhere between 20 and 30 seconds. So not sort of what I would call problematic. Filling those containers to the top, then you add several minutes to your reheating time. So there is quite a significant and non-linear difference in the reheating time when you start to fill the stainless containers to the top. And that's a clear observation. Now, what I was conscious of when I was testing these things out was not running the microwave for longer than 5 minutes with the stainless steel containers filled with food. And what I've typically done is sort of 2 minutes, then a good stir, and then a following 2 minutes. And that seems to work rather well. In a plastic container, the same amount of food would be hot in about 3 minutes or 3.5 minutes. So stainless is a little bit different, but I think not overfilling or filling the containers is a good approach, and that doesn't seem to create any sort of adverse effects or problems during the heating cycle. Does that clarify the point you were making?
Yeah, I just wondered if there's any work had been done. So, I mean, I understand
Yeah,
how metals work in microwaves. So I was just wondering if
of
you'd actually
course.
done anything
Yeah.
to gain any more information. But no, thanks for your answer.
Thank you, Greg.
Seems people are out of questions.
Okay, if I could just add something to Greg's point, because Greg, who I've only known in the last few months, is highly knowledgeable in this area. But I think what I've learned is that while we're at the sort of early stages of using stainless steel microwave safe boxes, there's a lot we still have to learn. And I think the product is good. I believe the product is good. But what I don't want to happen is that people start doing crazy things with them. I would sort of describe myself as a not crazy consumer. So I'll read things and then move forward reasonably cautiously, but still push the boundaries a little bit. But of course, when I was a young boy, I was a little more crazy. And what you don't want to happen is you start doing things in microwaves that create bigger problems. So I think for us in the stainless industry, this is a good product. It's an ability to move away from plastics reliance to some degree and improve our drive towards food safety. But what I've learned so far is important. It's not hard, it's just different. And we have to stick with that and make sure other people understand the need to be a little more thoughtful when you're using these boxes.
There's one more question about the
Yes.
energy consumption, comparing a microwave or another oven. Sorry, excuse me.
Yeah.
So yeah, so so what does it look like for one item cooked? I don't know whether we have that answer.
No, I mean, we've not done that direct comparison, and I use my food boxes in a conventional oven just as much as I do in a microwave. I think the one thing I've noticed is that I've got a 900-watt microwave oven, and for a portion of food, it takes somewhere between 20 and 30 seconds longer to reheat the food in the stainless container compared to a plastic container, same amount of food, same food in a plastic container. I don't think that is too problematic from an energy consumption perspective. Now, with a conventional oven, then metal boxes in conventional ovens are quite normal. Glass bowls equally quite normal. The benefit of a metal is it conducts heat faster. So I think with a modern conventional oven, you just have to be sort of mindful that probably the heating rate is a little quicker because you've got the heat transfer through the metal walls, particularly compared to glass. But you've no hygiene issues. So I'd say it's probably slightly faster, but not noticeably. So I
Would
don't
you like
think
me? Sorry, Tim. I was just
Sorry?
going to say, Camden have done some work on this. If you want, I could just
Oh,
pop out if
right.
you
I
want.
didn't. Yeah.
So yeah, we've if you Google energy use cooking and Camden BRI, there has been a
Yes.
white paper produced on the energy use of different appliances. So depending on the product, but for something like a baked potato, to cook a baked potato in a microwave is 5 pence UK. To do it in an oven's 50 pence. So there's a 10 times difference in the energy use. So there's plenty. Admittedly, these haven't been done with the metal containers, but given that
No.
the metal containers might not require a lot more energy, you'll be able to get an idea for that. So just Google, energy use, cooking method, and Camden BRI, and you can download a free white paper, and the information's on there for you to have a look at.
That's very helpful, Greg. Thank you.
Welcome.
No, that's brilliant because, as you say, it probably doesn't cover the metal boxes yet, but it will give us that guidance, which I think is always helpful to people.
Sure.
No, fantastic.
Yeah.
Thank you. Appreciate you joining this afternoon, Greg. That's great.
You're welcome.
There's another question, Tim.
Yeah.
How do you think that consumers are going to react to the costs involved?
I mean, that's a classic question because one of the big concerns that people have with stainless is the cost. And I think we have to look from a sort of different perspective. These products are really resilient and robust, and it is, buy once and it's forever. So I think we have to sort of sell the benefits in a very smart way to not have people fearing that this is just an expensive luxury that they don't need. But I think one of the things that's helping us is if you look around supermarkets now, you can go into most supermarkets and buy stainless steel water bottles. They're fairly common. And I think because domestic stainless steel products are more universally available, people are a little more attuned. Now, that doesn't mean, are these things going to suddenly fly off the shelves and the manufacturers can't keep up? I think it will be more of a slow burn. But I think as a society, we've got to wean ourselves away from materials that have more health concerns and move towards materials that are inherently safe, but have some, ways of treating them that are a little different. And certainly from my perspective, I think the hygiene factors are the ultimate strength of stainless, that you've got a product that has great versatility, but is, particularly when it comes to food preparation, safe. And I think we've got to sort of throw that out there without being disrespectful to other materials that have had their place in society, but things move on. So I'd rather be using materials that are safe from a health perspective than choosing other materials because they're a little cheaper. But it's the buy once and it's forever sort of approach. And I think one of the things I said to people in our office last year is put one of these on your Christmas present list. You know, get people to get them through slightly different routes as well. It doesn't mean you have to always buy them personally. I know us in the stainless world will rush out and buy one because we think they're good. But we've got to convince the rest of the people that aren't as wedded to this material and convince them with, you know, good sound reasoning that it is safe. It does mean you're getting something that will last forever and it'll always look good. And I think we've got to promote all those things. I think from a societal perspective, we've got to have a higher focus on sort of the health of our race and having less reliance on materials that are not good for the environment, are less resilient, and bring some sort of healthcare concerns. So I think we've got to play all those cards to try and promote the product. And I think there will be people that will latch onto it quickly, and there'll be naysayers as well. That's normal with anything that's different. And there'll be people that want genuinely convincing. And that's equally right. You know, people have the right to say, okay, this looks good, but, you know, prove it to me now completely. And I think we've got to address all those elements of society, all the different ways of thinking about things. But I think we can do that with this product, but we should take it cautiously. We shouldn't be bulls in china shops and say, hey, you must all get one of these now. This is the future. Because people think about things in different ways. And the last thing we want is to discredit our product by running too fast.
Oh, there's a hand raised.
Okay.
Shall I ask
Yeah.
them to speak?
Yes, ask the lady or gentleman to speak.
Okay, should unmute. So, hello, can you now speak?
Hello.
Hello.
Can you hear me? Okay.
Yes.
Thank
Yeah.
you for the invitation and thank you for sharing all this interesting information about this kindly use of a new use of stainless. The question is there a specific alloy to produce these boxes, or it can be produced from any alloy of stainless steel?
Yeah, that's an excellent question because it is an important consideration. And all the boxes that we have assessed in World Stainless are made using a 304 stainless steel 188 or 1810 type. So it's a very standardized, commoditized stainless grade. I believe there is one company, although I've not had any of their boxes, who are using a 316 variant for stainless steel. But as I said, I've not had that. But any common austenitic stainless steel, 304 particularly, 316 will work as well, will be perfectly satisfactory. I wouldn't advise using a ferritic stainless because I think particularly if you're using spicy or acidic foods on a fairly regular basis, then the cleaning may just be a little more challenging. You're likely to get some more surface discoloration. But I think the austenitic grades are good. And the reason I say that about ferritics is that I had an experience quite recently with a gent in the USA who'd purchased austenitic food baking trays in stainless and used those for a long time, and then purchased some replacement items, not for him actually, for a friend. And they were ferritics, and they stained very quickly in ovens, not in the microwave. And he ended up writing me an email, and then I called this guy and spoke to him. And he said, I don't know that they were any different. And when we examined on screen, he showed me the underside of these containers. I could see by the grade designation they were ferritic stainless. So it's not that it was a massive dilemma, but he wanted something that was easy to use. So ultimately, this guy went back to the supplier and got an exchange at no extra cost, which was rather good for him. He was quite pleased. But I think austenitics are the best grade for this. A 304 will be perfectly satisfactory. So I hope that answers the question.
Yes, but for example, in case we use ferritic 430, for example,
Yes.
it can be used. I mean, depends more on the design of the boxes than the alloy being used to use these boxes in the microwave ovens.
Well, I've not ever tried a ferritic box in a microwave oven, so I think there is a question there that probably needs answering, because of course you're dealing with a magnetic stainless steel in a
Okay.
ferritic rather than a
Oh,
non-magnetic. So I would have some higher concerns about that. With austenitics, excuse me, being non-magnetic, I have much more confidence in the use of austenitics, particularly in a microwave environment.
okay, Tim. Thank you very much.
You're very welcome. Any further questions, Joe?
No, yes, there's one more hand raised. So
Okay.
I'll unmute this person. He should be able to unmute himself now. Yeah.
Yes, that's Frank. Good morning.
Morning.
Out of my experience, I know that there are some boxes in the market made out of 200 series. It's also austenitic, it's non-magnetic, but it's 200 series, not just 304.
Okay, that's news to me. Thank you. I mean, it doesn't completely surprise me, and I can appreciate that a 200 series grade would probably work, but I've not road tested any of those.
No, I haven't tested them either, but I got them on the recycling base from a company which tried to put these boxes into the market, and they got some damaged boxes. They recycled them, and we checked the alloy, and
Of
we
course.
defined it as 200 series.
Sure. No, that's an interesting reflection, because I guess with the volatility as we know of the nickel price, 200 series could be an interesting option.
Yes, definitely.
Yeah. Thank you.
There's another question, Tim.
Sure. Yeah.
What do you think is the key reason for using a metallic box, like a stainless box, in a microwave oven without the risk of the electric arcing problem?
So I think the reason for using a material like stainless is that from a food safety perspective, it's one of the top performing materials. Glass is up there as well. So I think when we look at human health, then stainless and glass are excellent choices. But of course, when you come to metals in microwaves, I hope I've illustrated, there are some concerns because you want to avoid arcing. And the rules I've sort of laid out in a fairly simple manner do that. So the curved corners, the wide opening features, no sharp edges, all help to avoid arcing in microwaves. And as I said, I've used now 3 different brands over 15 months. I've never seen arcing once. And whilst this is a personal study, it's not given me any problems. So I think whilst we have questions about the suitability of other materials for reheating foods in our microwaves, and we now know that microplastics and nanoplastics are migrating into our food, and we're ingesting the equivalent of a credit card's worth of plastic every week. I think we need to do something to change, because plastics are not good for our environment with the level we're using them at. I'm not saying plastics are not good, but we're using way too much. We're potentially storing up some long-term health issues for people. And we should try and use materials that are not just reusable, but are fundamentally safe. And I think that's what stainless brings. So I know people will have concerns, questions, doubts, but if we don't embrace change, we could end up in a very bad situation in not too many years. And I think from a societal perspective, I think we need to sort of look at things a little more thoroughly and carefully, and of course challenge all the societal norms we have, and challenge the material choices. You know, if you're not convinced, just spend $20 and test one of these things out, because they work, and then you will be convinced. I mean, I'm preaching this because I feel compelled, having road tested these things for a while now, but I'm also part of the stainless steel industry. But you know, we know from a food hygiene perspective, it is without a doubt one of the best materials, and we should expand its use to good effect, and particularly when you have something that is infinitely reusable. You know, I've even taken one of my boxes and played football with my son in the garden to try and damage it, and you can't. You know, we've jumped on it. It's just indestructible. These things are beautifully made. As I said, there's a premium price on it, but you get lots of benefits. So I'd say have a go. Trust in the fact that the thing works, but don't do anything crazy. You know, don't put a box in a microwave oven with a spoon or fork left in it. You know, that's a metal on metal contact thing. People occasionally do those things, so you have to check. Have to be a little more careful, a little more observant, but they work. I hope that answers the question.
Hi, Tim. Can you hear me?
Yes, I can hear you.
Okay. My question is about the risk of electrical short circuit, because in the knowing of the general public, I can use, for example, a spoon or a glass or a knife. I can put in the microwave oven. This is the general knowing of the public knowledge. My question, a specific question, is why why I can't put for example, a spoon or a glass in the or metallic spoon in a microwave oven, but I can't put a box. What is the reason?
Okay, so to answer that question, if you took a spoon, and one of the things I've not mentioned yet is attached to this presentation are some appendices, and one of the appendix has a link to a video of a gentleman in the USA who has captured different materials, including metals, in microwave ovens. And he puts a fork in the oven, he puts a spoon in the oven. They don't arc. So what's interesting is single items that don't have sharp edges that are metal do not arc in a microwave. Now, once you start putting several items and they're in contact with one another, metal contact, you start to see arcing. So there are some interesting features about how metals behave in microwaves. And I think the first important learning is a single item not in contact with anything else, with no sharp edges, doesn't cause arcing as long as it takes up less than 30% of the volume of the microwave oven. That was one of my rules that I outlined. So There can be a problem with metals if you're putting metals in contact with each other, if you're putting metals with sharp edges into microwaves. But if you've got the right shape of thing, you've got a single thing like the containers or even a spoon, then you won't get arcing. And I think one of the things that's interesting is that people do crazy things from time to time. So if you're a manufacturer of a microwave, you don't want to encounter crazy things. So a simple rule that says don't put metals in microwaves avoids any crazy things. But I think as an intellectual society, we need to learn and learn that there are things we could do that we perhaps believed we couldn't do in the past. And so the people that are making these boxes have undertaken these assessments, and the TUV approval group are satisfied. But I think it's about the rules. You know, no metals in contact, not too much metal in your oven, no sharp edges. I believe it's possible to make frozen peas arc in a microwave oven, and they're not metal. So, you know, that is one feature that says, hey, this is not just about metals in microwave ovens. You can take frozen items that are definitely non-metallic and create sparking in your oven. So there's a lot of learnings here that people have to adjust to. I hope that answers the question in a fairly thorough way.
Okay, thank you.
There's a longer question here, Tim, which has to do
Sure.
exactly with these microwave producers, which you just mentioned. So it says, would it be possible to have the microwave producers' reflection or comments around using stainless boxes inside the microwave? What are they doing to challenge the norms? And arcing, can they support the development or transformation process?
Well, that's a really good question. And I've been in touch with a few people around the world from microwave trade associations, and we've agreed to set up a small committee to get everybody aligned here, because from a microwave manufacturer's perspective, what they don't want is things going wrong in a bad way, whether it's, you know, people getting injured, microwaves getting damaged, etc. But they accept that there is a sort of material transformation now with us. So they've agreed that we should find a way to sort of promote this in a safe manner, that it is a good product, it is a product that works, but it comes with some clear rules. And I think as long as, you know, we can all get agreement on that, and I think we will, because these people are not trying to fight against a change of material. They just want to make sure that there are no surprises, that everything's laid out in a simple and clear way for the use of stainless steel boxes in microwaves. And I think that's a good move from the industry, that they are willing to work with the materials producers. So I'm encouraged by that, and I think within a sort of few months we'll have perfect alignment there, and these things will be sort of fully endorsed by the microwave manufacturers themselves. So I hope
Thank
that
you,
was clear.
Tim. Yeah, it was clear to me. I hope it was to the audience as well. So one of the questions is, where can you buy these boxes? Are they selling, are they like sold around the world, or they're sold in like Mexico, or where are they sold? Where can you buy these?
Right, all the three brands that I've got, I bought online. And you'll notice some references of the images to people that are producing them. So I bought mine online, but I have seen some stainless steel microwave safe boxes in one or two supermarkets, not many yet. Carrefour in Europe has certainly stocked some. So they're not widely available except online just at the moment, but I think they will roll out into mainstream shopping channels fairly soon. So yeah, as I said, I bought all mine online. It was virtually next day delivery, 2 days maximum. when I got them. So they seem to be widely available. I think there are different promotional approaches in different countries. So I think South Korea, for example, has a brand there which is reasonably well established. I'm not sure the shopping channels there, but you can definitely buy that product online. So yeah, online is the most popular at the moment. Hope that's clear.
Okay, thank you. There don't seem to be any more questions at the moment, and it's in European Central European time. It's 9 o'clock, which means we've finished the hour. So I think we can close this session, can't we, Tim?
We can, and I'd like to thank everybody for their attention, for their attendance, for the questions, particularly because it's always the questions that become helpful and clarify things in people's heads. And maybe we don't resolve all the concerns just yet, because this is, I think, weird technology to some degree. We're pushing against the norm, but sometimes you have to do that to make progress. You know, and I'm quite pleased. I sort of class myself as a sensible consumer. I'm not going to do crazy things in microwave ovens, but I've not had any problems with these, and I think that's, you know, one reflection that's probably worth just considering. If I was crazy, then I would ask you not to follow my advice, but I don't think I am. So I'd like to thank everybody once more. Enjoy the rest of your days, and if you have any further questions, you can always contact us at World Stainless. So take care, and hopefully we see you at one of our webinars in the near future. Thank you, and bye-bye.